Hello and welcome to LFI Educates. Today we are going to learn in this video about the representation of position, displacement, velocity and acceleration in a plane. How do we represent it in a plane? Let us see. First of all, let us discuss about position, how to represent. A position vector we represent with this. Suppose this x-axis, this is y-axis, this is the origin. A line drawn from the origin to the point where the particle is. Suppose this is the position of the particle P. Then the line that is drawn from the origin up to this point P, we call it as position vector and we write it as R vector. R. This is how we represent the position vector. In case of position vector, if you resolve it, you already know that this is it will be R along x-axis I cap, and this will be R along y-axis, that we write it as j cap. If you write this value in terms of ax and ay, then you can even represent like this: position vector R is equal to along x-axis I cap plus y value along y-axis, y value along y-axis. This one you can write it as simply as like this also, as x towards x-axis and this is towards y-axis. The value we can take it as y. So this will give us the representation of position vector R cap. Its magnitude of position vector R is, magnitude we write as R is equal to root over x square plus y square, and direction of R along x-axis, if you take it as theta here, direction of R is theta is equal to tan inverse of y by x. Like this we can represent the position vectors. Just simply know that where the particle is, and if you draw one line from the origin, from the reference point, this is a reference point. From there, if you draw a straight line touching the particle, then that represents the, or that gives us the value of position vector. The second one, displacement. How to represent displacement in a plane? You take the plane. Suppose this is your xy plane. This is your plane. The object is moving this way. Suppose initially it was here and finally it came here. Then what we'll do? We'll take the help of position vector. This one will draw. Then let it be R1. And this one will draw it here like this, the position vector, final position let it be R2. And then displacement, as we know, is a change in position. So it will be final value R2 minus R1, final position minus initial position gives us displacement. So displacement, we'll write it as final position minus initial position so it will be R2 minus R1, position vector in terms of vector, if you write R2 minus R1. And just now you have seen the magnitude of R2 and R1, how to write down. The magnitude, if you write down R2, will write x2 I cap plus y2 j cap minus x1 I cap plus y1 j cap. In magnitude form if you write, then it will become x2 minus x1 I cap plus, this is plus, then y2 minus y1 minus y1 j cap. Like this you can represent the displacement vector, the magnitude of which will be magnitude of displacement in terms of vector. If you keep on writing, then this will become it's in terms of vector. Magnitude of displacement, it will be root over, this one you can write it as delta x also, change in position along x-axis I cap, better change it as delta I cap, plus this one delta y, change in position along y-axis j cap. Like this also you can write. Then here it will be easy for you to write delta x square plus delta y square. This will give you your magnitude, and after getting the magnitude you can find out the direction of displacement vector is equal to, we represent with theta, will be tan inverse of y value, that is delta y, divided by x value, that is delta x. This will give you your direction. So if you are learning here in terms of two coordinates, then here two terms are coming. If you are drawing one more coordinate for three coordinate, what will happen? You can see, you can understand delta x, delta y, next one will be delta z. That is the only difference. To write down the magnitude, it will be delta x square plus delta y square plus delta z square. Now let us see about the third one, that is velocity vector. How to represent velocity in a plane. Velocity is the change in displacement with respect to time. With respect to change in time. Displacement, just now you have written delta x I cap plus delta y j cap. If you know this displacement, change in time, we'll take it as delta t. Time is a scalar quantity. This one you can write it as delta x by delta t I cap plus delta y by delta t j cap. Position with respect to time gives us velocity, so it will be, let us take v along x-axis I cap plus v along y-axis j cap. Then magnitude of velocity, we can write it as root over vx square plus vy square, and direction of velocity we write theta, we can write as tan inverse of y value, that is vy divided by vx. So this will give you the velocity in plane. If you take two coordinates, three coordinates, then vz square also will come, and direction of velocity to get from this expression theta. Likewise, you can represent acceleration as well. The fourth one, acceleration to represent in a plane. Acceleration is equal to change in velocity. It is velocity divided by change in time. So velocity, just now you found out that value, if you put it here, vx I cap plus vy j cap, then it will appear like this. Vx by delta t I cap plus Vy by delta t j cap. Then velocity with respect to time, it is acceleration ax I cap and ax j cap. Then the magnitude of acceleration, we can write it as ax square plus ay square. So we'll give you the magnitude, and direction of acceleration, it will give you theta is equal to tan inverse of acceleration along y-axis divided by acceleration along x-axis. Like this you can represent this position, displacement, velocity and acceleration in a plane. So if you know position and displacement after that you have to know very nicely. Afterwards you can just follow the formula that you have learned in chapter 3. Just substitution only takes place, and these final results you should keep in mind. Now let us see about projectile motion. Now let us see the relative velocity in 2 dimensions. Relative velocity in 2 dimensions also remains the same as the relative velocity that we have discussed in 1 dimension. Definition remains the same. It is the velocity of an object with respect to another object in motion. The formula also goes the same way. VAB, suppose relative velocity of A with respect to B will be the difference between the relative velocity of A minus the relative velocity of B. And if you do VBA, relative velocity of B with respect to A, then it will become velocity of object B with respect to velocity of object A. The formula remains the same. The definition also remains the same. But a treatment, we'll do one numerical, then it will become more clear to you. Here is one question you can see. A man is walking on a level road with the speed of 4 km per hour. You can take man walking. This is the velocity of the man. It is 4 km per hour. Walking on a level road. Raindrops fall vertically with a speed of 5 km per hour. Raindrops fall vertically. Velocity of the rain, it is 5 km per hour. Find the velocity of the raindrops with respect to the man. You are asked to find out the velocity of raindrops with respect to the man. These are in terms of vectors. So generally when you do the solution, you will write down here Vm is equal to 4 km per hour. Then Vr, it is 5 km per hour. Then to find the velocity of raindrops with respect to man, velocity of raindrops with respect to man, it will be Vr minus Vm, Vr minus Vm. That means this Vm will have to take it in the negative side, this side will come Vm, this side is minus 4 km per hour, and Vr we are taking the positive direction how it was given. Now if you use the formula, this is Vr, it is in Vr value is 5 km per hour, it is along y-axis, 5 km per hour along y-axis is j cap will put, minus Vm is towards x-axis, so we'll write 4 I cap. Then you can find out the magnitude and direction. Magnitude of Vrm, rain with respect to man, magnitude of velocity with velocity of rain with respect to man is, you can write simply VRM, or if you put arrowhead, you have to put parallel bars. That is equal to, how we do earlier, a square x square plus y square, x square plus y square. These two values, the magnitude will find out, and the angle between them is 90 degree. Here you can see, so plus 2ab cos theta, cos 90 degrees is equal to 1, so cos 90 degrees is equal to 0, so everything will become 0. This is 25 plus 16, 30, 41 kilometer per hour. Like this you can find out. And to find out the direction of velocity with respect to man, as these two vectors, they are starting from the same point, the diagonal representing will give you the resultant velocity. This is VRM, we are finding out VRM, and the direction along with y-axis, if you take it as theta, and the direction of VRM is, direction of velocity of rain with respect to man is, theta is equal to tan inverse of y value, here if you drop on perpendicular like this towards y-axis, theta, this is perpendicular and this is the base. Perpendicular, you can see it is Vm, that is 4, divided by base, it is 5. Like this you can find out, and tan inverse of 4 by 5, if you don't know, you can keep it like this, and if it is given in the equation, the value, then you can put the angle. The angle is here 39 degree. Like this you can find out the direction. This is the way to find out the magnitude. This is the way to find out the direction. The next very interesting topic, an important topic you are going to study, is about projectile motion. A body that is in flight after being thrown or projected and whose motion is governed by gravity alone is called a projectile motion. Suppose a body, or you can take like this is the ground, this is a football, suppose somebody comes and kicks the football, then we know that the ball will be in flight. After it is in flight, it will come down and fall on the ground. This type of motion, initially you have to give some velocity. After that, no fuel is required for its flight. It will go by itself and then come down towards the ground. This type of motion, we call it as projectile motion, and the path traced by this projectile, the path is called its trajectory also, and the shape of the trajectory is your parabola. We call this shape as parabolic shape. The path traced by a projectile is called its trajectory. That means along which path the body is moving. This is its trajectory, and the shape is called a parabola. The path is a parabola. It follows a parabolic path. So this is your definition as well as the path of the projectile. Now mathematically let us see how the path of a projectile is a parabola. Now let us see the equation of path of a projectile. We'll take it like this: y-axis and x-axis. This is the origin. Suppose a body is projected or thrown with an initial velocity u. Let us take it as u. We'll write down like this: at an angle theta with the horizontal. Let a body be thrown with velocity u at an angle theta with the horizontal. Then resolving this u into its components, if you drop perpendicular here, you will get here u cos theta. Base and hypotenuse will give you cos theta, u cos theta. Resolving u into its components, one will be u cos theta in the horizontal direction, and the second one will be u sin theta along the vertical direction. If this is u cos theta, then this side will be u sin theta along the vertical direction. So these are the two components of velocity u. Now this u cos theta, the horizontal component of velocity, the horizontal component of velocity u cos theta remains unchanged. Throughout its motion. Why it remains unchanged throughout its motion? Because there is no acceleration. Once it is thrown, done. The work is done. Along the horizontal direction, there is no acceleration in the horizontal direction throughout its motion. Since there is no acceleration, but the vertical component of velocity, that is u sin theta, will keep on changing. But the vertical component u sin theta changes. Why it changes? Because when it is going up, the acceleration due to gravity will become lesser and lesser as it reaches the highest point, C suppose, then it will stop there, it will become 0. Then again the velocity will become more and more. The acceleration due to gravity will change. There is acceleration, downside is becoming more and more. Here acceleration due to gravity in the upward direction, downward direction it is plus g, and in the upward direction it is minus g. So because of the change in acceleration, the value of u sin theta also will keep on changing during its motion. But the vertical component u sin theta changes as g changes. The acceleration due to gravity keeps on changing. Now suppose at any instant of time t, the particle has reached this point P. Say the value of x coordinate is x and y value, let us take it as y only. This side it will be y and this one it will be x. Suppose at any instant of time t, let us take the object that is thrown, or a body, we have written body, the body reaches point P, xy. Then considering the motion along the horizontal direction, considering the motion of the body along the horizontal direction, your displacement is along x-axis. X is equal to uxt plus half of acceleration along x-axis, let us say ax, we write t square. But as there is no acceleration along x-axis, as we have mentioned here, u cos theta will remain unchanged towards motion since there is no acceleration. Ax value is equal to 0. So x is equal to ux, velocity along x-axis is u cos theta into t plus this will become 0 since acceleration along x-axis is equal to 0. So from here what you can get is t is equal to x divided by u cos theta. Let us mark this equation number 1. Now let us consider the motion along y-axis. Considering the motion along y-axis, your y component displacement is y, and the body is at point P, the displacement is y. Y is equal to velocity along y-axis into time plus half of acceleration along y-axis t square. Here also we are using the second equation of motion. Now y is equal to uy, velocity along y-axis is u sin theta t into t plus half of, when the particle or the body is at point P, it is in the upward direction, so acceleration due to gravity, we will take it as minus g t square, then it will become y is equal to u sin theta into t plus, no, plus to minus is minus half of gt square. Let us mark this as equation number 2. Putting the value of t from equation 1 in equation 2, putting the value of t from equation 1 in equation 2, we get y is equal to u sin theta into t is x divided by u cos theta minus half of g to t square into x square divided by u square cos square theta. So there you can cancel it out. Y is equal to sin theta by cos theta is tan theta into x, or x tan theta you can write down, x square divided by u square cos square theta. Let us mark this as equation number 3. Since theta, u and x, since theta, u and x are constants, sorry, theta, u and g, the expression due to gravity, x and y are variables here, are constants. Therefore, equation 3 can be written as y is equal to, this one you can take it as a, x tan theta I am taking it as a, minus, or you can write it as plus also, not a problem here. All the term, constant term, you take it as b. Then this is x square. That is the equation number 4, where a we have substituted for tan theta and b is equal to minus, we took half of g divided by u square cos square theta. So this equation, equation 4, represents the equation of a parabola. Equation 4 represents the equation of a parabola. Hence, the path traced by a projectile is a parabola. This one you should be able to show. If you can show y is equal to second degree equation, you can see x square, then the equation represents a parabola. This shows that the path traced by a projectile is a parabola. Now let us see the expression for time of flight. Time of flight of the object in parabolic path, we will write it as t. It is the time taken by the projectile it is the time taken by the projectile or time taken by the body from the point of projection point of projection is O, till it reaches the ground or till it strikes the ground. Let us take it as B, till it reaches the point, till it strikes the ground, till it strikes the ground at point, till it strikes the ground, say. You can write here B. Now, to find out the time taken by the projectile, first of all, from O to C, up to the highest point, to find out, there will be the time taken to reach from O to C, how long it will take. The same time will be taken from C to B. So if you can find out from O to C, suppose time taken, I'll write down here, time taken to reach, or time taken to travel from O to C is the same as the time taken from C to B. The time taken would be the same. Let it be C to B. Let it be, say, T by 2. From O to C, we'll measure it. It will be T by 2. This is the highest point at which the projectile reaches the topmost point. Now you see here the initial velocity you have applied you have applied the velocity, and then when the body reaches at point C, the velocity will become 0. So Uy will be 0. So let us use the first equation of motion, the velocity using first equation of motion along y-axis. You will get V is equal to U plus AT. This is your formula. Write down the first equation of motion. It's along y-axis, along y-axis, along y-axis. Time is t. The remaining values. Velocity at the topmost point is 0. The final velocity is 0. So Uy, velocity along y-axis is U sin theta. It is U sin theta plus acceleration. As the body is going up, the value of Ay will be minus g, and the time to reach from O to C, as we have mentioned before, will take t by 2. T by 2. You can note it down the values, since Vy is equal to 0 here, Uy is equal to U sin theta, and Ay is equal to minus g, acceleration is minus g, and time is equal to, we are taking t by 2, half the time taken, that is from O to C. So this one, if you transpose it here, minus gt by 2, you will get U sin theta. Minus will become plus. So from here, instead of finding t by 2 directly, you can find t. T is equal to 2U sin theta divided by g. Let us mark this as an equation. Let it be equation number 5. This expression, with this expression, you can find out the total time taken by the projectile to move from O to B. If you find t by 2, it will be half the time again. T by 2, if you double it, it will become t. So instead of doing it twice, you can do at once t. T is the time of flight. Directly you can get the expression. And let us see the horizontal range. Horizontal range, we write it as R. It is the maximum horizontal distance from the point of projection to the point of striking the ground. it is the maximum horizontal distance from the point of projection to the point of striking the ground. That is point B. That is from O to B. This is your horizontal range. OB is called a horizontal range. To find out mathematically, horizontal range R is equal to this distance. Distance is equal to velocity into time. Velocity along x-axis, velocity along x-axis multiplied by the time of flight. Now R is equal to velocity along x-axis is u cos theta. In the time of flight, that is t. Just now earlier we found out it is 2u sin theta divided by g. So R is equal to u into u is u square. Then you have 2 sin theta cos theta. Trigonometrically you have value for this. 2 sin theta cos theta is equal to sin 2 theta. This is your formula, trigonometry formula, divided by g. This gives us the expression for horizontal range. Since you can write the formula sin 2 theta is equal to 2 sin theta into cos theta. This value is equal to sin 2 theta. So this is the expression for horizontal range. But for maximum horizontal range, suppose you are playing shot put, then at what angle you have to throw so that it reaches the farthest distance. Then how you can find out from here? For maximum horizontal range, the value of sin theta, the highest value is 1 for sin theta. So here sin 2 theta you have. Sin 2 theta should be equal to 1 for maximum horizontal range. Then sin 2 theta 1 is equal to sin 90 degree. Sin if you remove from both the sides, 2 theta is equal to 90 degree. So theta is equal to 90 divided by 2. It will give you 45 degrees. So remember that if you play shot put or javelin throw or discus throw, whatever it is, you need to throw at an angle of 45 degree. Then only it will go for maximum distance. Horizontal range will be maximum. Now for this maximum horizontal range, R maxima, suppose if you are asked to find out the maximum horizontal range, then what formula to be used? Sin theta is sin 2 theta is equal to 1. So it will become u square by g. So you can remember this as a formula for getting maximum horizontal range. We will use this formula, u square divided by g. U is the initial velocity. Now let us see the maximum height attained. You can see in the diagram, this is the maximum height. H I have written here up to the point C. So the maximum height attained, or we'll write it as h, maximum height. It is the maximum vertical distance the body moves above the point on the ground, from the point of projection also we can say, from the ground, the highest point, we call it as the maximum height. Maximum vertical distance, to find out this vertical distance, we'll have to take the motion along y-axis, motion along displacement along y-axis, displacement along y-axis is y is equal to uyt plus half of ayt square, s equal to ut plus half of at square. Now here the maximum vertical distance, we are calling it as the height of the, or maximum height of the projectile or the body. uy is your velocity along y-axis, that is u sin theta, and time taken t to reach from O to C, as we have said earlier, then it is t by 2 plus half of body going in the upward direction will minus g. Again here t square, so it will be t by 2 whole square. Then this is u sin theta into t by 2 is u sin theta divided by g. Earlier we derived t is equal to 2u sin theta divided by g. So t by 2 will be half of it. So 2, if you make it half, it will become 1 u sin theta by g. Added here, plus into minus is minus half of g, and t by 2 this time whole square. If you square it, it will become 4 u square, sorry, t by 2. Then this 2 will not exist, 2 will come down here. T by 2 is u sin theta, so it will be u square sin square theta divided by g square. Like this it will come 1g, you can cancel it out here. Then ultimately what you will get here is u square sin square theta divided by g and minus half of u square sin square theta divided by g. These terms are common, you can see here. This is 1, this is minus 1 by 2. 1 minus 1 by 2 is 1 by 2. So your formula will be u square sin square theta divided by 2g. So this will be the expression for maximum height attained by a projectile. So let us do one numerical and see using these formulas how you can calculate it. So here is one equation for solving the equations that we have derived. A soccer player kicks a ball at an angle of 30 degrees with an initial speed of 20 meters per second. The angle given as 30 degrees and initial speed is given as 20 meters per second. Assuming the ball moves in a vertical plane, calculate the time at which the ball reaches the highest point. They are not asking the total time of flight, half the flight, that's t by 2. Number 1 will do like this: the time at which the ball reaches the highest point, the time at which the ball reaches the highest point we write it as t by 2. T by 2, and your formula is u sin theta divided by g. Put the values. U is 20, sin theta, theta is 30 degree here, angle is 30 degree, and g value is given to you 10 meter per second square. So take 10, 10 2s are 20, 2 into sin 30 degree is equal to 1 by 2. So you will get 1 meter. we are finding out the time, so it will be in second, 1 second. Then the second one, maximum height reached. So the second one, if you do the maximum height reached, the maximum height reached, we write it as h. The formula is u square sine square theta divided by 2g. So here also you put the values u square 20 square into sine square 30 degree divided by 2g will be 2 into 10. This is 400 into sine square 30, 1 by 2 square divided by 10 into 20, and cancel it, 2 20s are 40, so it will become 20 into 1 by 2, the square is there, so 1 by 4 it will become, then 4 5s are 20, this is 5, height you are finding out, so you write meter, like this you can calculate it. Then the third one, the horizontal range of the ball. To find the horizontal range, your formula is r is equal to u square sine 2 theta divided by g. So put it here, u square 20 square into sine 2 into 30 degree divided by g is 10, so it will be 400 into sine 60 degree is root 3 by 2, and right here into 10, 2 20s are 40, 20 root 3 range it will be in meter, and write it as 20 root 3 meter. And ultimately the time for which the ball is in air, it is total time of flight. Number 4, total time of flight, we write it as t. T is equal to u sin theta divided by g. 2 into u is 20 into sine 30 degree divided by sine 30 degree divided by g is 10. This is 4 into sine 30 is 1 by 2, 2 to the 4, so it is 2. Time you are finding out, it will be in seconds. Like this, you can calculate the numericals provided you know the formulas you have to know it, then you can put the values and calculate. Thank you and have a nice day. Stay tuned with LFI Educate. We'll continue in our next video with circular motion.